For this video, I will be looking at coronal holes and solar-induced changes of the Earth's magnetic field, along with previous examples of where such has also coincided with tectonic instability and at times anomalous weather. When this coronal hole was brought to my attention on March 24, I was tempted to run with a post that included this information along with a heads up for increase in earthquake potential. This would have been for anywhere in the world during the last week of March. Even when New Zealand saw a magnitude 6.8 quake the other day, on the 26th of the 3rd, I was hesitant to explore this realm of science at the fear of public ridicule. But here we go anyway. Seeing as a more powerful magnitude 7.7 earthquake impacted Myanmar, it is due to the ongoing and notable trend I cannot hold silent on what should be considered, especially when it comes to current solar and geomagnetic conditions we observe. What we have seen this last week of March can somewhat be compared to a similar example from October 2003, where we saw the largest coronal hole ever observed in the satellite era, since observations began in the 1950s. Destabilized geomagnetic conditions ahead of multiple solar flares potentially led to a range of tectonic and atmospheric instability at this time. This potentially led to the Iraq 2003 magnitude 6.8 earthquake, which devastated the region. But it was also an event accompanied by Aurora and sudden stratospheric warming events, exacerbated by an already tough El Niño year for the globe. Weather was influenced by notable changes in the jet stream, arguably exacerbated by solar activity. But El Niño in 2003 must also be considered as a dominating climate driver for this time period. For the following, consider all relevant sciences and take these examples with a grain of salt. Here are some further examples from the past. A coronal hole along with CMEs dominated space weather in September 2021. Mid-latitude aurora was noted and a magnitude 5.8 earthquake struck Melbourne, Victoria on the 22nd of the 3rd. Fast forward to the end of 2021 and the start of 2022. The Tonga eruption had no notable geomagnetic disturbances at the time, but can easily be considered as part of an ongoing cycle where pressure increases due to mantle upheaval below the crust of the Pacific plate. This event in January 2022 changed atmospheric moisture levels for years ahead worldwide. Solar activity in early February 2022 saw over 40 Starlink satellites fall from orbit before the East Coast low hit southeast Queensland and New South Wales later that month. This would include the Lismore floods of 2022. Aside from Elon losing some satellites, correlations drawn here about the sun and environmental impacts are minute, so this is not much of a case study. What triggered the East Coast flooding in 2022 is rather linked to La Niña, more accepted versions of climate change, and likely influences from the Tonga eruption that happened 1 to 2 months prior. Jump forward 1 year, and solar cycle 25 continued its approach towards an 11-year solar maximum. February 2023 saw a large coronal hole along with CMEs within this month. Turkey and Syria experienced a magnitude 7.5 quake with 50,000 plus lives lost, being a compelling and memorable case for a connection between coronal holes and earthquakes. During March and April 2023, we saw consistent and enhanced solar activity with multiple coronal holes and full halo CMEs. This ended up being a big month in solar and climate sciences. In March, global temperatures rapidly rose to the supposed mark of 1.5 degrees above pre-industrial levels. This is where the Earth has held ever since. Multiple papers have discussed how feedback mechanisms within the Earth's mantle may have had a warming resonance with the Earth's atmosphere. This is a fascinating topic and one I'd like to explore further. During March 2023, G4 geomagnetic conditions led to mid-latitude aurora, closer to the equator than what we are used to seeing. Not long after, tropical cyclone Ilsa slammed into the Western Australian coast as a Category 5 system. That was on April the 6th, 2023. Fast forward a few months, and another coronal hole, along with G2 and G3 geomagnetic conditions, occurred in September 2023. Storm Daniel also formed in the Mediterranean during this month, impacting Greece, then shifting south to devastate Libya. 10,000 plus lives were lost during this event. Alongside this, mid-latitude aurora and a magnitude 6.8 earthquake also struck Morocco, killing 2,900 plus people. A magnitude 7.1 and 7.6 earthquake also occurred in the Philippines and China during the month of December 2023. March 2024 was when we began to really see the enhanced geomagnetic effects created by minor solar activity. G3 geomagnetic storms were caused by just M-class solar flares in some cases. May 2024 was considerably the most incredible aurora display in 500 years. G5 geomagnetic conditions were produced by consecutive solar flares within that month, multiple X-class with full halo CMEs. 1 week later, one of the strongest tornadoes ever recorded hit the town of Grenfell, Iowa in the US, with wind speeds measuring at 518 kilometers per hour. Within the US, 570 tornadoes formed in that month alone. Volcanoes erupted in both Indonesia and Iceland. Floods in Brazil and Afghanistan also displaced 3 million plus people and are considered particularly historic for these nations. May 2024 certainly was a big month. Around August 2024, multiple sudden stratospheric warming events occurred, disrupting the Antarctic polar vortex, events occurring in rapid succession. The total of 3 sudden stratospheric warming events occurring in just a 2 to 3 month time span is also record-breaking. This was on the back of some pretty intense solar activity, of course. Solar activity was seen, in this case, to instantaneously and directly affect the climate in Australia when a sudden stratospheric warming event shifted winds in South Australia to favour desert northerlies. This went on to produce record temperatures for South Australia in August 2024. Record high pressure in the previous month of July also saw Leeuwarden in Tasmania reach its new coldest temperature record at -13 degrees. This is also a new Tasmanian record. It is hard correlating solar activity to climate, especially when the record cold and heat are produced by similar events during similar time periods. What sudden stratospheric warming events can do for one region can do the opposite for another. Muswellbrook in the New South Wales Hunter region, east and central Victoria, along with Perth, also saw earthquake swarms around these coronal hole periods back in August 2024. For Muswellbrook, this ended up going until November. I am still not sure if this is at all mining related, but with the earthquake swarms produced here, I assume it is something related to tectonic behaviour and the Great Dividing Range. For January and February 2025, this year, we have also seen CMEs, coronal holes and mid-latitude aurora during this time period. So far, there is little to note when it comes to making any connection with solar activity and, say, our bizarre monsoon season. However, TC Alfred may have shifted towards southeast Queensland after rapid expansion in high pressure to the south in the Tasman Sea. That was early March, however. It is here in late March where we see a significant coronal hole event with a continuing pattern of unstable tectonic activity present, this time in New Zealand and now the earthquakes in Myanmar and Southeast Asia. Back on the 24th of March 2005, our Sun produced one of the largest coronal holes we have ever observed, at a whopping 978,000 kilometers wide. This is roughly 7 Jupiters wide. We'll first look at solar-induced changes on the Earth's magnetic field, but where we find most scientific conjecture is around the solar and geomagnetic relations we consider for lithospheric processes, mantle upheaval, and plate tectonics. This is via mantle induction and electromagnetic feedback. And the other is atmospheric processes and climate via solar stratospheric coupling and sudden stratospheric warming events. Lithospheric processes, mantle upheaval, and plate tectonics are potentially influenced by changes in geomagnetism by the following 2 mechanisms. 1. Geomagnetic field and mantle convection. Mantle convection drives plate tectonics and mantle dynamics, and is primarily powered by heat from the core. While the core generates the geomagnetic field through the dynamo process, the theory suggests that variations in the geomagnetic field could potentially influence heat flow patterns in the mantle. The second is electromagnetic interactions. There are speculative hypotheses suggesting that changes in geomagnetic activity could affect electromagnetic fields in the mantle. The Earth's magnetic field is linked to the flow of electrically charged particles in the outer core and could theoretically influence mantle dynamics to some extent. However, these electromagnetic effects would be weak and are considered insignificant compared to the thermal and mechanical forces that dominate mantle processes. Although this video is more focused on solar lithospheric relationships, we can find through solar stratospheric coupling in the atmosphere another way in which increased solar and geomagnetic activity can cause changes to the Earth. Studies have shown a link between solar activity and the upper atmosphere, where increased geomagnetism can cause sudden stratospheric warming events and potentially lead to changes in the jet stream and polar vortex. In some cases, instantaneous increases in high pressure and low pressure have also been noted, but attempts to make a direct correlation here is highly contentious. Perhaps discussion for another time. While the full understanding of this process is still evolving, it plays a role in the dynamics of Earth's climate and weather systems. Solar-induced changes on Earth's magnetic field include discrete and momentary events, but factors like the migrating North Pole and South Atlantic anomaly suggest the weakening Earth's magnetic field will continue to surprise us for generations to come. The dipole moment represents the strength and orientation of the magnetic source, in this case the Earth's magnetic field. When the magnetic field weakens, unprecedented amounts of cosmic and solar particles bombard our planet, which can also potentially influence the climate on Earth. Increased cloud cover as a result of increased cosmic rays is such a study, but is still seeking an overall scientific consensus on the matter. Nevertheless, we keep an eye on how the magnetic field continues to weaken and follow the various effects it has on our planet, including the North Pole as it continues to head to Russia, and don't forget about that South Atlantic anomaly either. Thanks for watching the video, and stay tuned with Weatherman Dan for more information and content.